right, I would say, Max, I think people may still chime in as they're walking up, but I still want to kick it off so that also then gives us a little bit more time and you more time in the presentation. Max, you told me that, because I always ask people, what do I learn from this session? Why should I be here? Why should they be here and stay here? You said you are teaching us how easy it is to actually build a serverless platform on WASM.
Yes, how easy it can be.
How easy it can be, okay.
Because sometimes very difficult, complicated, failing, but it can make fun.
Yeah, but after watching this, we should have an idea on how we can make it easier. Now, Max, to your person, you're also an organizer of KCD Munich.
Correct.
So you know all the challenges when it comes to organizing a big event like this, but you also know the joy when you actually then get things going and when you get on stage and present. Yeah, you're welcome to Vienna. And Max, I think that's all I wanted to say. The floor is yours. And later on, we'll do some Q&A. So folks, remember your questions. We have the other Andreas standing here later on for Q&As. All right, Max, go ahead.
Perfect. Thank you very much. Cool, awesome. Great to be here. Thank you for the invitation. Max Körbächer is my name. I'm, as Andy said, organizing also the KCD Munich. So if you would like to make the Alpine round, you can come next year to us in Munich. And maybe a month earlier or later, there's also going to happen the KCD in Zurich, I guess, again. So you can make a nice Alpine trip. Besides this, I'm a CNCF ambassador. I'm also part of the Linux Foundation Europe Advisory Board and running also a technical advisory group within the CNCF for environmental sustainability. So if I'm not being the founder and the cloud native advisor for Liquid Reply, which is a consulting company in the end, I close this work computer, go over to my other Mac, open it up and start working on open source. Sometimes my wife is asking me, are you still working or doing your hobby? So I don't know, it has a fluent border. And today we are going to talk about WASM, WebAssembly. Who has heard of it? Okay, I can go. Perfect. So if everyone has heard of it, if you haven't heard of it, this is what you will find in Google. When you Google fast forward, it gives you a little bit broad picture of what it could be, what it is, what it maybe isn't. But the documentation around is, well, continuously expanding and going very rapidly into a very deaf's corner, which sometimes doesn't provide this very good, nice experience if you want to try out a new technology without going back to university and study again the 5-6 years for getting understand how this really works. So this is often kind of problem with WASM. However, it has some benefits. It's comparably fast if you want to start up some applications. On the left-hand side, you can see a diagram where it's compared to have a WebAssembly application starting up. You barely can see the line because this is around 50 to 55 milliseconds, right? It's fast enough that you can shut down the service completely, and if you call it, it spins up, answers your request, and goes down again, and you will not feel it. That's perfect. Lambda on the other hand side looks almost slow to it. It's 200 to 250 milliseconds if it is very small, way more if it's a little bit more bigger. And so the startup time is, well, getting bigger and bigger for a Docker container and a VM. On the other hand, it's very lightweight. If you have a WASM container which is around 3 to 4 megabyte, it feels already quite big. I've seen some which is below 1 megabyte. And we also have used one for our implementation for the Boston Dynamics spot, where we try to keep it as small as possible because we want to be able to transfer it over very, very bad wireless communication mechanisms. So you need to go on a very, very small level. And it's secure. It sometimes can be a trap. Nothing on this planet is secure by default, and nothing on this planet is infinitely secure. But the default settings for WebAssembly are generally secure because it denies everything. If you do not tell what the WASM application is allowed to do, it will not be allowed to do anything. It's just exists in its own ecosystem, like in a bubble, and that's it. It's sandboxed, and that's one of the reasons why it comes actually very handy in the browser technology, because you can leverage that everything runs within your browser, but is isolated from your operating system and from your host. But we also need to be clear what WASM isn't. It's not a programming language. It's not a replacement for JavaScript, even though it runs in the browser. It's not a container replacement or will, I don't know, make Kubernetes vanish, because we're today in a Kubernetes community day. We're more looking on how to leverage the Kubernetes ecosystem for it. And it will be also not the answer for everything. It's not the ominous number 42, because it has some downsides which not always will allow us to use it in every kind of case. So what it is good for? Well, on the one hand side, there's an infinite long list of browser stuff. And I'm not a browser dude, so forget about it. I can't tell you so much about it. But on the other hand side, we have a very nice and interesting development on the server side. We see it with untrusted code in an isolated environment. We see it for backend application. And here is happening frequent development. Practically in the last year, every month there was a major release, either from some commercial companies or from some open source organizations who are working on WASM and pushing the boundaries of WebAssembly in the backend further and further and allow more and more use cases. And this talk is actually based on an update which was given, I think, 2 weeks ago, like in the beginning of September. Before that, it would be a little bit more complicated to do so. So when we take a look about WASM and utilize it for building a cloud, we need to think about a few ingredients which we require for baking our little environment, and which is cloud native enough to maybe even be considered as a cloud itself. And because it's Christmas time, I don't know how it's here in Austria, but in Germany you get already your Lebkuchen, which I found disgusting because last week it was like 25 degrees and my Lebkuchen was melting in my hand. But nevertheless, let's take a look in the baking receipt for this. On the one hand side, I'm talking today about the Spin framework. Why? For the developer experience. Sometimes it feels kind of hard to really work with WebAssembly and to make your code properly compile, especially if there is a new pre-build or a pre-release. I don't know, anyone felt this frustration of using WASM and compile something to it and make it run? All happy, fantastic. Cool, that's great. But it's not what we can relate to some of the big organizations we're working with where they experiment with. We frequently get told, hey, it's a fantastic technology, I would like to use it, but man, I have a hard time to make it run. But also because they have very restricted environments. So Spin or Fermyon Spin is a kind of very interesting ecosystem because you can find all kind of different things on the platform, but also around it. So Spin is a CLI, you can run it locally, you can run it in your pipelines. Spin is a runtime, and then you have Fermyon Cloud where you can execute your Spin application practically. And it's very easy and straightforward because you usually do not have to do so much with the application itself. If you have once built it and throw it into the cloud provider from Fermyon, which doesn't load perfectly, then you will see there is not so much things you can do. This is not AWS. You do not have 300 different services which you can call. This is just purely to execute some WASM applications. And it's fairly easy. Ta-da, it runs. And this application is built just as a short look around what else you can provide. However, why it is important to understand that this exists? Well, because you have an end-to-end story. Wherever you would like to build something with Fermyon Spin, you can run it locally, you can run it on your cloud, you can run it in your Kubernetes, you can run it in the Fermyon cloud, you can build your own cloud. And this is the kind of user experience which you actually would like to have, right? You also have the same promise with container. Build once a container, it runs everywhere. Well, we all know it's kind of bullshit because build once a container, it doesn't run here because you have something there, you maybe need some network policies here, and so on and so forth. So usually it's not that easy and simple. So for Spin, the whole experience to get up and running and get something running on your machine is very, very straightforward. The first thing is you say spin new, perfect, typo. And then you choose what you would like to have. In this case, I will go for the HTTP Go, because this is what the framework of Spin has already implemented, an HTTP handler. Also one of the difficult things in WASM to make network communication in some way happening. So this is pre-built. You can see there's tons of different programming languages, and also you have possibilities to talk to Redis and also to provide a static file server. We need to give this thing a name, and a location, and a path, and that's it. So with this, you will get a kind of boilerplate from Spin with a tiny Go manifest or with a tiny Go file. Very straightforward. And from there, you can start developing as you would develop everything like a regular feature set. For sure, do not pull unlimited amount of libraries and anything else into it. The more dependencies you pull, the more likely it maybe will get some problems. And when you're done, then we can build from this an application. For the definition of this, we have the Spin TOML, where we give some additional metadata, and we tell also Spin what is the command to build this container or to build this WASM module. We could change it here if we want to, but usually we don't have to. Oh. I'm the wrong folder. Spin, build. And with such small application, it's usually also quite fast. Sometimes you will see that it requires a long time to pull all the dependencies. And maybe that's also here the case, because when I tried earlier, it's kind of fast. And then you will get your main.wasm file. You all will know it, because you all use WASM, but just as an explanation to people who do not know it. And then you can just bring it up, right? And it's going to run and say, hello, Fermyon. So fairly easy. The good thing about this procedure and this whole process, you can leverage it to the whole development toolchain. Doesn't matter what you're going to do, from local development to your testing, scaling up your application, share it with your colleagues. It works actually quite smoothly and is very, very fairly easy to use, and allows you to bring the application also into any kind of platforms which has some Spin in the background running. The other reason why we're talking about bringing Fermyon to a kind of cloud-ready platform state is about one of the latest updates from the DICE Labs people, who in the beginning of September released a feature for the Linux container to run side-by-side containers. Sounds very boring, sounds like a problem which was solved like 2019-ish, something. But that's not true for running a container and running a WebAssembly module in a pod deployment together. So what we now can do, what is now allowed, is to have one pod definition and having one part of it running a regular Docker container with whatever you would like to have in it. And on the other hand side, having a container running the WASM module. Again, it can be any kind of WASM, it can be Spin and so on, doesn't matter. But this is what this new feature allows us. And therefore, it opens us a new field to integrate with Dapr. Dapr is a distributed application runtime. Because what you now can do is to pull out dependencies for databases, for messaging, for security, out of your WASM, out of your application, and just move it over to your Dapr agent. So you can just communicate within the same setup between the WASM module and the Dapr agent, which runs practically in the local host, quote unquote. And they can exchange this information. The cool thing about Dapr itself is also that it can run again kind of everywhere, and it can integrate with any kind of databases, message streaming, and so on. So it's like an abstraction layer which you now can put around your WebAssembly, and whatever else you have on the other side running, databases, message streaming, security, you do not care, or someone provides for you, but you can exchange it. And this allows you to build a fairly stable environment for running an internal platform. It has tons of different integrations for managing your state, act as a handler, and so on and so forth. It also would be possible to utilize an SDK and directly integrate Dapr with your code. But there are some problems at the moment to bring this then alive in WASM. It's something which is currently under development. However, what we can do is to do HTTP calls. And because now both containers sharing practically the same environment, we can do this HTTP call on the local host with the same machine, on the port which you would like to have, and that's it. Super easy, fairly easy to use. So how does a normal local setup then looks like? Well, we need on our machine a spin framework running, maybe Dapr as a CLI. We need a container runtime, and then we're already good to go. Because with the setup, we can run spin and spin up to make the WebAssembly application available. Through Dapr, we can run the Dapr agent, make the Dapr agent available, and that's it. Then we need some configuration, where's my database, my message streaming, and both can communicate very easy with each other. The best thing is, it looks exactly the same on a cloud. And you can use Docker Compose, you can use Kubernetes Helm, whatever, to deploy this whole setup, either within Kubernetes or without any Kubernetes. This is fully up to you. So from my perspective, this is a full, true cloud-native approach to provide such applications. Because even though you live within an ecosystem, within WASM, within Kubernetes, within container, you can fairly interchange everything what you have within the system. For sure, you have dependencies like on a spin, like on a Dapr, but everything around you can exchange and configure as you would like to have. Full flexibility, same behavior, literally same behavior. So let's have a look how this looks in real life. There's a very nice demo from Dice Labs. Can highly recommend this. You can find the Dice Labs demo, and there's different levels and different applications there, written on Rust, written on .NET. This is a polyglot demo. You can bring it up in live on your machines or on your Kubernetes environment in around about 15 to 20 minutes. And then you have more or less the same experience and more or less the same setup. So first have a look on the application. Here's a Barista API. And the Barista API doesn't have any super duper specific built-in. We have a few dependencies, and we have here also the Spin SDK, because we need to do the HTTP calls. And we need to handle the HTTPs and get also like the requests. What you will also see is like we give an environment variable for the Dapr URL, because we need to know at which point we can just do the calls. Behind this is, for example, a local host, let me lie, 3051 or something like this. And then there's a lot of handling of features and the request and so on and so forth. And then, for example, down here on the button, you see like, okay, here we push the order update and give it back to one of our public and subscribe mechanisms. Whatever is behind, right? I don't care. This can be a RabbitMQ, a Kafka, whatsoever. Hands up, whatever you provide me as a cloud platform, I will just utilize. As a Rust, you will have a cargo toml. You will have also the spin definition. Big thanks to Tang, who practically built this demo. And then we have the Docker file to build the container for the application, for the API. Also here, nothing very specific or special in it. You don't see at all that there is a spin framework running behind it, right? This is a typical process of bringing the Rust application to a WASM module and then just to put the WASM module in from scratch container to make it execute. The only difference is that you have a spin toml which makes the configuration for the HTTP handler to know where to go and where to write the requests. On the cluster side, we have to do a little preparation, which we can find with the components for the Kubernetes. We have, for example, the Dapr configurations. And here you have, for example, the component where we take a look on the Barista pub/sub and where we define through the metadata, like where to find and what is the name of the Redis server and what is the password. As you see, security is one of my heart, and I use a super safe security password. But what is more interesting when we go down here, we see that we actually don't do, again, something super duper special if you would like to deploy this WASM container. It's a random and kind of normal deployment file. The only big change which we see is the runtime class, which is set to WASM time spin. That's it. This is the only change which defines between like a WASM and a regular container what is going to happen. We see here the local host for the data URL, which is given in as an environment variable. And there's no other big magic going on. And then, well, the runtime class is actually the most boring YAML file which you can find in it. For sure, you need to have installed it before. So what I'm running here in our demo, when we go over, and I hope it's still connected. When we go over to our demo, and what you can see here is running is just regular the pods, which can all be communicate with it. You can get the different services which are exposed, for example, for the Redis, for the APIs which we have deployed. But you can also see the components for the different APIs which we have deployed to configure Dapr, for example. Right? So everything lives within the Kubernetes. And this makes it actually quite straightforward to be utilized in this whole cluster because we bring in a very new technology, very new, I mean it's kind of old, but very new to the backend world, and leverage the whole Kubernetes ecosystem, the flexibility of the cloud native ecosystem, and seamlessly let it integrate it. For some people, it doesn't look like a big magic because, well, you know, we have this already all with the containers, and it works like this since 5 years with containers. But the exchange of the runtime and having now a fully secure, isolated, and sandboxed application turns around the whole story, because when you think further about it, this is what allows you to build internally a multi-tenant platform running any kind of application. And the best thing is you almost don't need to worry about what it is in, because it's so much sandboxed. If you take a look on how much effort you need to spend to really isolate a container and make it super safe and secure, and then you bring it to a CISO and they're looking on it and like, it's still not super secure. Well, yeah, you're right. We would need to go always one step further, right? We would need to isolate the nodes, and we need to maybe spin up a micro VM to empower more isolation and so on and so forth. And then it starts feeling dumb, because if you run on a cloud provider, then you have your Kubernetes environment where you needs to spin up a virtual machine in which then you run your Docker container and whatsoever to isolate. I don't know, for me it doesn't feel very logic. Nevertheless, coming back, overall the architecture which you have seen looks kind of this. There will be a little bit struggle if you try it out with the .NET, because it's .NET 8 preview. And sometimes it's a little bit like, doesn't want to work. But what is very helpful to understand is how we can really utilize the Dapr and the spin together to communicate seamlessly and very easy with a provided service for Kafka, Redis, whatsoever. And in this context, this often brings us also to the discussion about serverless and serverless v2. For some of the people running out there, they're like, oh, serverless is serverless. It will be an evolution in it, and this is going to happen. But this is from people who often work with AWS Lambda, which are like this since years. And they're kind of slow and boring and very isolated. You cannot transport it very well. You cannot bring it to any other platform. The developer experience, if you live in this ecosystem, is good. But the way into this ecosystem is very long, and then you're locked. So on a serverless v2, what we actually have just shown you is it's very fast. It is portable. You can bring it everywhere. You can even utilize, as long as you can touch the node of a Kubernetes, you can even then utilize there the machines. This will not work for every cloud provider, but for the most. And you can make this also work end-to-end in every of your testing. So there are some myths around, but because I'm running slowly out of time, we often hear like, oh, WebAssembly is so fast. And I also told you it's fast, but it's just fast in the startup. The execution time of your programming language always depends on your programming language. This doesn't change. right? So there's a little miss in it. Also because it's small and fast, we often hear like, oh, it's sustainable. I wish it would be. Would make my life as a technical advisory group for environmental sustainability super easy because I can just sit in my chair and say like, people just go to WASM. But it's not like this. You need to optimize the whole system still. Security, we talked about it. It is secure, but it's not infinite secure. And it also will not replace containers. However, I strongly believe that WASM will be omnipresent because we see it in the front, we see it in the back end, we see the ecosystem adapting. And we see it more and more coming up. Big cloud providers going to adapt to it. And yeah, the future of it is bright. I think Web3 and the cloud native ecosystem is also like merging slowly into each other for some good and for some bad reasons. But nevertheless, the rest of it we can talk by coffee or water, or maybe in the evening by beer. So thank you very much.
Awesome, thank you, Max. I will definitely take you up on having a beer with you tonight, which is a reminder. The evening reception, if you have not registered, but you want to enjoy drinks and beers, well, drinks are beers, I guess. Well, anyway, beers and food, then please register. We have 3 more minutes time for questions, and we have our mic runner again. So, folks, do me a favor, if you have a question, then raise your hand. Here we go, 7th row, all the way over there.
So the Spin platform, you have to first install it to your Kubernetes cluster for all this to work, and also Dapper or something like that, yeah?
Yeah, but it's actually just one command to get the shim running on your environment.
Is it like an operator, or is it something different?
There are different ways how you can do it. So you can install the Spin framework on the Spin runtime as itself, as a standalone. You can install it through an operator, to also works with the KWASM operator. It's actually developed by my team. It's open source, which you just like install in the Kubernetes and takes care for everything else. Yeah, or you use the cloud provider for it.
Okay, thank you for the awesome talk.
Anybody else? Here we go. A little bit on the back there. 1, 2, 3 steps. 5, 6,
You will be done in the evening, right? If you run the all day up and down.
Exactly. Yeah.
Thank you. Can you tell me a little bit about how it works with the managed cloud services, like the GKEers or other services?
Mm-hmm. So practically, as long as you can touch the host, it's not a big problem, right? With AWS, it's the most easiest one because you can always configure and change the image as you wish. Also with Azure, you can preload your cloud init and adjust to it. With GKE, it's sometimes a little bit difficult. So depending on the configuration and if it's on autopilot or not, then there we don't see so much success. With many other cloud providers, also in the European area, it also works more or less smooth. The cool thing is if you use the KWASM operator, then it will always run somehow and somewhere. I just would not recommend to go production with it. Right? It's actually made for running locally on K3D, K3S, micro-K8s, whatever you want to have. You can run it on the big Kubernetes, but it's not made for running in production for this purpose.
Now I got a quick question for the audience, not only who has the next question, but who has used Spin before? Yeah, okay. Perfect. Last question, last chance for a question to Max. Go once, go twice.
Maybe. You showed on one slide the sidecar that you need. And since I already have an SDK that I need to use and we are compiling anyways, why can't I compile all the logic of that sidecar into my binary?
Mm-hmm. So this is something which is currently under development, to put Dapr and the Dapr SDK directly into the programming language. But Dapr doesn't, so you have like a little bit mismatch between which programming language is supporting WebAssembly and which are supported by Dapr. So when you try to do it currently, you cannot use all of the functionalities because they're quite dynamic and there always needs to pull in some information. You can do it with some of the environment variables, but it's not the best thing to always like throw in the environment variables because you bake them hard into the WASM. which is like, yeah, you do not want to see in a cloud-native environment. That's why it's at the moment very smooth to have it just as a sidecar running, which you can configure and update as you want. It literally don't care about what's happening in the backend, which data is happening, and so on and so forth. Maybe in 1 to 2 years, the story will look different, and you can directly bake it into.
Cool. Perfect timing. Thank you, Max, again. Applause.